square number. You can have a product of 5 to have 25. 25 becomes your square number. More like, let's say 12 times 12, you'll get 144. 10, product of 10, you can get 100. And many other counting numbers that you can multiply by themselves so that you get the product. That product that you get after multiplying a counting number itself is the one we refer to as a square number. In the same sense, we also need to look at a flashback as far as square roots are concerned. It is inevitable to look at square numbers without mentioning square roots. So in the same way, we need to recall square roots. What's a square root? A square root is a number that produces a specific quantity when multiplied by itself. I repeat, a square root is a number that produces a specific quantity when multiplied by itself. There is a symbol for a square root. Do we recall the symbol for square root? How I wish we all write it. Write it down there. That is a symbol for the square root. My dear, how do we find square roots? I know we have ever looked at that. Square roots, for example, we can be asked to find the square root. Find the square root of 144. Find the square root of 144. When we are finding square roots, with the help of our symbol, we do prime factorize the given square number. And when we are prime factorizing, we only use prime numbers. Do we recall prime numbers? I believe we do. A prime number is a number with only two factors, 1 and that very number. Numbers like, we can have examples of prime numbers. Numbers like 2, 3, 5, 7, or I know you have written 9. No, please, 9 is not a prime number. Write 11, 13, 17, 19, 23, 29, among others. Such numbers are the ones that we use when we are looking at square roots under prime factorization. How do we prime factorize? For example, we have 144. We can use a factor tree or a ladder. For this case, let's choose a factor tree. Since 144 is an even number, we can start dividing it by 2, since 2 is a prime number. When you divide 144 divided by 2, we get 72. Still 72 is an even number, therefore you can still divide it by 2, and you come up with 36. Furthermore, 36 is an even number. When you divide it by 2, you'll get 18. Still 18, even divided by 2, you come up with 9. 9 happens not to be an even number. We have been dividing by 2. That means we shall check on the next prime number whether it is exactly divisible by 9. And indeed it is. So we shall go to 3. 9 divided by 3, so 3, and by 3 is 1. We end up having them in pairs. You get these prime factors in pairs. You have a 2, you pick one digit from the pair. So 2 and 2, I will pick a 2. 2 and 2 paired, I will go with a 2. Then 3 and 3 paired, I will go with a 3. Now, how do we get the square root? The square root of 144, you write it as under root, is equal to a product of 2 that you have chosen and another 2 that you have chosen, and another 3 that you have chosen. So 144 under root will be given by 2 times 2, which is 4, 4 times 3, which is 12. 12 becomes the square root of 144. Wow, I think we have brainstormed enough on square roots, square numbers, and prime numbers. For such more lessons, I encourage you, my dear friends, to visit the Prime Learn. Prime Learn is an application that helps a learner to learn from anywhere and at any time. How do I get Prime Learn? Prime Learn can be got from visiting your Google Play Store, download the application onto your gadget, tap in it to register. When it opens, go to my account. You will fill the credentials as are required. For example, your active email account, your phone number, your name, and later on you will create a password of about 9 characters. You sign up. On signing up, you will be provided with a mobile code in SMS, which you will enter and send, for a confirmation. By doing so, you will be able to access the best lessons and lesson tests prepared by excellent teachers of different subjects and classes. Remember, Prime Learn at the moment, it caters for primary going children, including nursery. So the lessons range from nursery to primary 7. I urge you to learn with Prime Learn and learn ahead of others. Now, back to our lesson, which is about Pythagoras' theorem. Let us keep all what we have flashed back at, for example, the squares, the square roots, and the prime numbers. Such information is very crucial in what we are going to look at tonight, which is the Pythagoras theorem. What is a theorem? Before we look at Pythagoras theorem, we need to know what is a theorem. A theorem is a mathematical statement. It is a mathematical statement proven by many examples and expressed as a symbol or a formula. My dear, we are going to look at what we call Pythagoras theorem. Check the spelling, Pythagoras theorem. And the question is, what is a theorem? A theorem is a statement, is a mathematical statement. A theorem is a mathematical statement proven. A theorem is a mathematical statement proven by many examples, and expressed as a symbol, or a formula, That is the meaning of a theorem. Now, Pythagoras' theorem was proven and named after a Greek mathematician and philosopher called Pythagorean. In his experiments, he based on right-angled triangles to come up with the theorem. And these right angles, the right-angled triangles that he based on, the experiments were practical and diagrammatical. With me, I have come with a diagrammatical experiment of the Pythagoras theorem. However, for him, he used a lot of materials, both practical and diagrammatically, to conclude with the theorem. This is a diagrammatical experiment on the Pythagoras theorem. We have three colors on our diagram. We have the green, we have black, and red. Hope you are able to see them. When you look at the green part down, it has got 9 squares. Then the black at the side, there are 16 squares. Above all, inside, there is a right-angled triangle. There is a right-angled triangle. Being represented, the right-angled triangle must obtain that symbol, implying that there is a 90-degree angle in it. Now, after obtaining the green squares, 9 of them, and the black squares, 16 of them, we go to the side of red. The boxes in red, or the squares in red, are 25. Quickly find me the sum. Quickly find me the sum of 16 and 9. Quickly find the sum of 16 and 9. Wow, that sum is 25. After obtaining the 9 squares down and the 16 squares onto the height, the other slanting side has given us 25 squares. Such experiments, both diagrammatical and practical, were done by a philosopher called Pythagorean to have come up with a conclusion that the sum of the squares on the base and the height of a right-angled triangle is equal to the squares on its hypotenuse. When you have a right-angled triangle, there is a base, there is a height, and the slanting side, which is called the hypotenuse. And after several examples, we are saying the wise man Pythagorean concluded that the sum of the squares on the base and the height of a right-angled triangle is equal to the squares on its hypotenuse. We are saying when you have your right-angled triangle of this nature, there must be that symbol to show that it is a 90-degree angle. This is called the base. We have the height. And the slanting, which is the longest side, is called the hypotenuse. It is called the hypotenuse. Check the spelling. Hypotenuse. So after several experiments, it came out that the sum of the squares onto the base and the squares onto the height added is equal to the squares onto the hypotenuse. Remember, sum in mathematics means addition. My dear, how does this theorem state? I know Most of us now know the facts about the theorem, but how does it state? The Pythagoras theorem, the Pythagoras theorem states, Pythagoras theorem states that the sum of squares on the base and height of a right-angled trapezium, rather of a right-angled triangle, is equal to the squares on its hypotenuse. That's the fact about the Pythagoras theorem. After several examples, it was proved that the sum of the squares on the base and the height of a right-angled triangle is equal to the squares on its hypotenuse, the same triangle. And it is also known that these are three sides of a triangle were named after this theorem, since a theory is expressed as a symbol or a formula. We have three letters that we use to stand for the lines as the base, the height, and the hypotenuse. Remember, Pythagoras theorem only works on right-angled triangles with the Pythagoras triples. Do we know Pythagoras triples? We are yet to know them. How do we name these sides? Hope we can look here and see the naming of these sides. Hope we can look here and see the naming of the sides. This is our right-angled triangle. And that right-angled triangle, we said we have the base, the height, and the hypotenuse. Those are the sides. But they have been given different letters. Letters A, B, and C stand for these sides. Where letter A stands for the base, letter B stands for the height, and letter C stands for the hypotenuse. When we are using these letters, kindly use small letters. And we are going to come up with a formula that summarizes the theory. And that formula is from the theory that the sum of the squares on the base and the height of a right-angled triangle is equal to the squares on its hypotenuse. We are going to base on that, and we come up with a summative statement that we shall be using when we are looking for the hypotenuse. It will be very hard for us to keep on writing this statement forever whenever we face such questions. In this, we are going to base on the formula, it's the statement itself, and we say that when we square the side of the base, which is now A, plus the square of B, we end up with the square of C. Since we have seen on our diagram that there are 9, but initially there were 3 squares. Now when you square 3, you come up with 9. And initially there were 4 squares onto the height. When you squared 4, we came up with 16. And initially there were 5 boxes. When we square 5, we come up with 25. We are going to base on this fact and say that the sum of the squares, instead of writing this statement, the sum of the squares on the base and the height, we shall have a simple statement that A squared. A squared stands for the squares on the base. A squared stands for the squares on the base. Then plus B squared. Now B squared is standing for the squares on the height. The squares on the base are being represented by A squared. Then on the height are being represented by B squared. Is equal to the squares on the hypotenuse. And the squares on the hypotenuse, are now being represented by C squared. One shall say A plus B squared gives us C squared. Hope we have understood this, that where A is rising from the squares found at the base, then B squared is rising from the squares found on the height. And lastly, C squared is originating from the squares formed on the hypotenuse. And this is what we shall be using whenever we are asked to find the hypotenuse. We shall be saying A squared plus B squared are equals to C squared. One may ask, where is the addition sign coming from? Look here on that underlined word, sum. In mathematics, sum is the total, or is the answer that we get after adding. So we have replaced the word sum with any operation sign, which is plus. So we say A squared plus B squared equals to C squared. It is coming from our theory that was proven right by many examples carried on by the philosopher Pythagorean. Can we now look at how we find the hypotenuse with the help of the theorem, which is A squared plus B squared equals to C squared? I believe right now we are able to see the examples. How do we find the hypotenuse? Since our lesson was aimed at finding the hypotenuse of a right-angled triangle by the help of the Pythagoras theorem. Allow me to erase this. Hope you have jotted down. Hope you have put this down. I have later advised you that for any academic need, you need to visit the Prime Learn. Download it on your phone. Move with the app onto your phone so that you can learn from anywhere and at any time. One may be asking, what is the spelling of Prime Learn? Here is the spelling of Prime Learn. Here is the spelling of Prime learn. This is what you type in if at all you want to download the app, Prime Learn. For all your education needs, visit the Prime Learn. We want to look at the examples of how we find the hypotenuse. And right below this, write what we say, finding hypotenuse. So finding the hypotenuse. The hypotenuse is for a right-angled triangle. The hypotenuse is for a right-angled triangle. And that right-angled triangle must be with the Pythagoras triples. They can pose a question that find the hypotenuse. By the way, the hypotenuse is the longest side on a right-angled triangle. So instead of asking for the hypotenuse, they can say find the longest. Find the longest side on the triangle below. Find the longest side on the triangle below. You need to know that the longest side is the hypotenuse on a right-angled triangle. And here come our diagram or the triangle. Right angle in it. And we have, let's say, we have 5 centimeters and we have 12 centimeters. Asking us to find the hypotenuse, which is the longest side. How do we find it? How do we find it? This is how we go about such a question. We are going to derive this from our theorem, which states that the sum of the squares on the base and the squares on the height is equal to the squares formed on the hypotenuse. And we have got our letters to use, that with the base we use letter A, with the height we use letter B, and the hypotenuse we use letter C. So we shall substitute these letters in our statement that A squared plus B squared gives us C squared. A squared plus B squared gives us C squared. We shall further go and substitute. Where there is A, we put the length of the base. Where there is B, we put the length of the height. And where there is C, we put the length in case it is there. Since it is not there, we shall maintain our C. So we have 5 squared plus 12 squared is equal to C squared. But what does 5 squared mean? And what does 12 squared mean? 5 squared is the same as 5 times 5 added to 12 times 12. We are getting 12 times 12 from 12 squared, is equal to C squared. There we have 25 plus 144, giving us C squared. Let us quickly get the sum of 144 and 25. Let's get the sum of 144 and 25. Surely we get 169, equating it to C squared. But we need the value of C. C squared is C times C. Now, what number do we multiply by itself to get 169? This is what It means when we reach this step, we ask ourselves, which number do I multiply by itself to come up with 169? We may not be able to predict the number there and then. Rather, we introduce the root 2 sign. So we find the square root of 169. Still, we shall also find the square root of c squared. Right, we have earlier on brainstormed on how to find the square roots by the help of square numbers. How do we find the square root of 169? By the help of square numbers, we keep on checking whether it is divisible by a given prime number. If not, we go to the next prime number. For example, 169, is it exactly divisible by 2? No. If not, we go to the next prime number, which is 3. When you look at 169, is it exactly divisible by 3? Check out and see. When you add 1 to 6, it will be 7. 7 to this. It will not give you the sum of a multiple of 3. So, it is not exactly divisible by 3. When you look at 5, it doesn't end with 5. Still, it's not divisible by 5. We go to 7. No. 11. Let's try out 11 and see. Perhaps you have realized it doesn't. What of 13? What of 13? Try out and we see. Right, 169 is exactly divisible by 13. So we shall use 13. 169 being divided by 13 is 13. And when I divide 13 by 13, I'll get 1. I will pair my 13s and I pick 1. So I'll remain with only 13. It means that the square root of 169 is 13. So 13 is equal to C. 13 is equal to C. But when you look at our dimensions, they had units. It implies that also the hypotenuse must have the same units. Then you will conclude that therefore C is equal to 13, but the 13 are in centimeters. So C is equal to 13 centimeters. C equals 13 centimeters. You have answered the question which is asking for the longest side. It is asking for the longest side. Because when you look at this, it's 5. When you look at this, it's 12. It means the 13 sided in length, the 13 in length is the longest on top of the other 2. So that is how we do apply our Pythagoras theorem in order to find the hypotenuse. Look at it. Hope you have jotted it down. Hope you have jotted it down. I want us to look at the last. I want us to look at the last example. Hope you have jotted this one down. I want us to look at the last example before we start interacting. I want us to look at the last example before we start interacting. Hope you have followed the steps. The most important thing is to know which side is A, which side is B, and why are they squared. That will give us a clear reason as to why we can find the hypotenuse using A squared plus B squared, equating it to C squared. Another thing is you to know about the finding of square roots. You need to know how to find square roots by prime factorizing. It means the prime numbers must also be at your fingertips. Prime numbers like 2, 3, 5, 7, 11, 13, 17, they should be at your fingertips. At the moment, I want us to look at number 2. I want us to look at example number 2, which we need to do together. Find the hypotenuse. Find the hypotenuse. Find the hypotenuse of the figure below. Of the figure below. Find the hypotenuse of the figure below. And our figure is the right-angled triangle. In that nature, there is a right angle somewhere. It can be drawn in any form. A right-angled triangle can be drawn in any form, but the most important thing is to realize. For example, we can say this is 12 centimeters, and this is 9 centimeters. Whenever they draw a right-angled triangle, you need to know which is the base, which is the height, and which side is the hypotenuse, which is the longest side. How do we identify this? You can have a triangle drawn in this nature, facing down. You don't need to think a lot. For as long as you see this symbol here, the right-angled symbol, or the symbol of right angle, when you see it, the two lines on which the sign is, one is the base and one is the height. The sleeping one is the base, then the standing one is the height. That is how we find the base, or we determine the base and the height of a right-angled triangle. Just look at where the symbol of a right angle is, then you see the sleeping line will be the base and the standing one will be the height. Let us look at this example very fast before we start interacting. And they are still asking us to find the hypotenuse. From a squared plus b squared gives us c squared. We shall look at this a, b, and lastly c, implying that we shall have 12 squared plus 9 squared gives us c squared. We furthermore interpret the squares like 12 times 12 plus 9 times 9, which will give us c squared. Still, we are from multiplication. When we multiply 12 and 12, we shall get 144, added to a product of 9 and 9, which is 81, equating to c squared. We shall get the sum of 144 and 81. Hope you have added it from there. Yeah, and you must have come up with 225, equating it to c squared. Now here, we ask ourselves, which number do we multiply by itself to come up with 225? There, without hesitation, we apply the root symbol. We apply the root symbol. And we say 225 under root is equal to c squared under root. We go ahead to prime factorize 225, because the root of c squared is c. We look at that, 225, we can prime factorize by the help of prime numbers. It ends with 5, not divisible by 2. We can start by 3. When we start by 3, when we divide by 3, we get 75. From 75, can we divide? Still divide by 3? We now get 25. From 25, who has realized the prime number to use? 5. Thank you. 5, when we divide by 5, we shall get 5. Lastly, when we divide by 5, shall be 5. You pair the 3s, you come up with only the 3. With the 5s, you only come up with the 5. It means 3 times 5 is equal to C, implying that 15 equals to C. But you remember, there are units that you have been given, which are centimeters. It means the hypotenuse is also in centimeters. So C gives you 15 centimeters. That is how we find the hypotenuse. The most important thing is to know which is the base and which is the height. Then also to know how to prime factorize in a bid to see the square root. Wow, it's high time now we interacted. It's high time we interacted. When you are telling me such responses for such numbers that I'm putting forward, I know you have been following, and we are going to quickly know what we have been looking at. How far have we understood this? By answering these fewer questions, there are 3 questions, and I expect my lucky callers to be with the answers. For example, the question is, find the longest side. Find the longest side on the following triangles. All these triangles must be right-angled triangles. Right-angled triangle 1 is here. Let me hope you are ready for the calculation. My right-angled triangle 1 is there. I have 6 centimeters down and 8 centimeters on the height. Triangle 2 is here. I've said it can be drawn in any form. This has been drawn in that form. This has been drawn in that form. You need to know how you find the hypotenuse on this. Let me say 3 meters, and we have 4 meters there. We need to get the hypotenuse on triangle 2. And lastly, triangle 3. Lastly, triangle 3 is here. Triangle 3 is there. We have 12 centimeters and 16 centimeters. All of this require us to find the hypotenuse. I know you will come up with a squared plus b squared equating to c squared. You are using this.
Hello?
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 I'm getting you, dear. What is your name and where are you calling from?
My name is Okonya Jasmine.
Yes, Jasmine.
My name is Jasmine.
Yes, Jasmine. Thank you for calling. Which answer are you giving?
I come from Mukono.
Yes, please.
I come from Mukono.
Yes, Jasmine. Thank you for calling from Mukono. How are
I'm
the Mukono
answering
people?
number 1.
Yes.
I come from Mukono.
Yes. You're answering number 1. Please go ahead.
Yes.
Go ahead to answer number 1, dear.
64 plus 36
Yes.
equals 100.
Please.
Therefore, the square root of 100 is. Therefore, square root.
Yes, the square root of 100
is 10 centimeters.
Therefore, the square root of 100 is 10 centimeters. Wow. Thank you, Jasmine, for correctly answering number 1. For whoever's been calculating, Jasmine, thank you so much. Greetings to all the Mukono people, and thank you for tuning on Star TV. I encourage you to keep on. For whoever's been answering number 1, Jasmine has I've answered it first. 10 centimeters. Very true. She has told us the square of 6 is 36. Added to the square of 8, which is
Hello?
64. Yellow.
Yes, this is Mr. Assad calling you from.
Yes, please. Your name and where you are calling from? Hello. I was saying that Jasmine has added the square of 6 and the square of 8, which is 36 plus 64. She has come up with 100. And to get the square root of 100, she came up with 10 centimeters, which is very correct. Now, what we called Pythagoras triples are 6, 8, and 10. Those are the Pythagoras triples. And remember, we have said that Pythagoras theorem works on Pythagoras triples. Yeah? Hello? Yellow. All right, keep trying calling, keep trying the calls. Yes, please.
Hello?
Yes, dear.
My name is Meina.
Your name is? Yes, tell me your name and where you're calling from. Please. Which number are you answering? Hello?
My name is Melinda.
Yes, Marina. Where are you calling from, Marina? Hello?
Sorry, number 2.
You're answering number 2. Please go on.
From Salama.
Yes, from Salama. Answer number 2. Continue and answer number 2. Marina,
9 plus 16.
Yes. 9 plus. I don't get you clearly. Yes, Marina?
The answer is 25 meters.
The answer is 5 meters. You must have got the answer from 16 and 9. Thank you so much, Marina, calling from Salama. Greetings, all the Salama people. Thank you. I urge you to keep on learning on these programs to Some on Star TV. I wonder whether there is anyone who can answer number 3 as we go. Yellow. Anyone to answer number 3? I thank you, Marina, who has given me 5 meters on number 2. And she has called from Salama. Any other caller to answer number 3? Any other person to answer number 3? Wow, as we wait for anyone to answer number 3, I want to thank you, my dear ones, for learning with us on Star TV Emunyenye Gwanga. I encourage you to keep on. On different days, we have different subjects and different teachers running the lessons live on Star TV. Yellow. Hello.
Hello.
Yes, please.
Hello.
Yellow. I'm getting you. What is your name?
My name is Naula Joan.
Your name is Joan. Thank you for calling, Joan. Where are you calling from?
Coming from Mutungo.
Mutungo. Mutungo. Yes, are you answering number 3? Joan from Mutungo?
The answer is 16 centimeters.
The answer is?
16 centimeters.
16 centimeters. Number?
Number 3.
Number 3, 16 centimeters. Thank you so much, Joan, for trying. Thank you so much, Joan, for trying. But I believe there is a small error. There is just a small error in your computation. I believe there is a small error in the computation. 16 and the 12. No, there is something small.
Hello?
Yes, please. But thank you for trying, Joan. Just correct that small error. Yellow.
I want to answer number 3.
Yes, please. Answer number 3. What's your name and where are you calling from?
My name is Raymond.
Yes, please. Thank you for calling in. We are answering number 3.
I'm calling from Makindi.
Yes, please. Thank you for calling from Machindi. May I get to know the
My
answer for
answer
number
is
3?
20.
I beg your pardon? I've heard him pointing at 20.
My answer is 20 meters.
Your answer is 20 centimeters. Wow, thank you so much. Thank you so much. 20 centimeters. Wow, I feel like being here for the rest of the day. However, I'm caught up by time. Thank you so much. Thank you so much for being with us. Yes, please. Any more callers? Any more callers? Thank you so much for being with me in this lesson. I'm so happy that we have managed to answer all the numbers that we have put. My sincere appeal to you is keep trying out different examples. You can now use the same numbers to find the base. You can use the same numbers to find the height, if at all you have the hypotenuse. I loved your interaction. Thank you so much. At the moment, it is time for us to be out. I only call upon you to download PrimeLearn application for your online education solutions. I remain Agre Gerard Skayongo from Victoria Mtunde Primary School. For now, may the good Lord bless you.
Oli mu kulaba Star TV emmunyenye y'eggwanga. Bannayuganda bannange, tukimanyi nti tuli mu kaseera ak'akazigizigi ak'obulwadde bwa COVID-19. Wabula tetusaanye kwerabira nti waliwo endwadde ze tubadde nazo okumala ebbanga ddene, era nga mu ndwadde zino mwe muli bilharzia wamu n'ebiwuka ebireeta okuzimba mu mbuto zaffe, trachoma ng'onaleeta okuziba amaaso, wamu n'enjovu ereeta okuzimba ebigere. Endwadde zino ziruma bangi okwetooloola ensi, naye okimanyi nti ziyinza okwewalibwa ng'okola bino wammanga. Ekisooka, okunaabanga mu ngalo ng'okozesa sabbuuni n'amazzi amayonjo. Ekirala, okunaabanga feesiyo ng'okozesa sabbuuni n'amazzi amayonjo. Weewala okukwata mu maaso n'engalo enkyafu. Bulijjo kozesanga kaabuyonjo. Era vumirira nnyo omuze ogw'abo abagenda nga beeyambirayambira bwe basanze ku kyalo kyo, kubanga kino kireeta ensowera ate ezireeta obulwadde. Buli lw'owulira nga tewawulira bulungi, okubirizibwa okugenda mangu eri omusawo. Era jjukira okukuuma obulamu wamu n'okwekuuma ggwe. Obubaka buno buva mu Minisitule y'ebyobulamu ng'eyambiddwako Ascend Project.
UBC Radio 98 FM.
Moru dus UBC Radio.
Amaru UBC Radio programs me Sunday.
Radio me UBC. Apoyo.
Your programs are so informative. I love them so much.
Your music rocks me.
Nyumirwa nnyo kuwuliriza UBC Radio kubanga abantu baayo bakola ekiriyo.
You are listening to UBC Radio.
UBC Radio, inspiring Uganda.
Tosubwa ku Star TV.
Obadde okimanyi nti ensi yattu Uganda eyimiriddewo ku by'obulimi?
Enkumbi teringa.
Naye abange, kiki ekiviiriddeko eby'obulimi, obulunzi wamu n'obuvubi okuddirira mu ggwanga?
Ebyennyanja tebiteera kulabika bulungi.
Kiki kye wandyagadde gavumenti okuteeka mu nkola okuyamba abalimi, abavubi wamu n'abalunzi okuganyulwa mu pulogulaamu eza gavumenti? n'egattaako buli lwa bbalaza okuva ssaawa emu ey'akawungeezi okutuuka ssaawa 2 ez'ekiro nga nkutuusaako pulogulaamu obulimi zaabu ng'abasomesa abakugu mu by'obulimi obulunzi wamu n'obuvubi nga bakuwa amagezi butya bw'oyinza okwejja mu bwavu ng'oyita mu nkola ey'omulembe. Nange Haruna Muteesaasira.
Tosubwa ku Star TV.
Kadongo kamo nnyimba ezijjudde obubaka obuyigiriza ate era obuzimba omuntu. Yatandikira ddala mu mirembe gy'abaddaani mugula bamatiya luyima ne basebadduka.
Abagagga be babintumye bekokola bafa babafiitina.
Wuuyo najja ng'asenvula okutuusa ku mulembe gw'aba basudde Wile Mukaabya, Paul Kafeero ne basebatta. Kati nno omusingi omulala mungi ogututte Kadonka mu maaso. Muno mwe muli ba Walukagga, mwe muli ba Vincent Segawa, ba Hassan Ndugga n'abakyala nga bajja Kikizzo. Twegatteko buli Sande ssaawa 11 okutuusa 12 ku Star TV. Nange Bulamba Margaret na Lumansi Tasubwa.
Tosubwa ku Star TV.
Oyagala okubeera omumanyi mu byabufuzi, byanfuna oba byanjigiriza? Tosubwa buli lwa mukaaga essaawa 2 okutuukira ddala ssaawa 4 ez'okumakya mu pulogulaamu yaffe ebifa mu ggwanga wano ku Star TV emunyenye y'eggwanga.